quite a good group of experts. And in order to manage this this new session, I have another one of my ICAO colleagues, Mr. Miguel Marin. Miguel is the chief of the operational safety section, where he oversees a lot of the technical aspects that support all of civil aviation, including airworthiness, operations, licensing and training, global tracking, aircraft registry, language proficiency, and various other things. Before coming to ICAO, Miguel worked as a pilot at Mexicana with several thousand hours in Boeing 727s and A320s. But he's been a very good partner to us in RPAS over the last few years, providing all sorts of guidance and input to us. Miguel.
Thank you, Leslie, and good morning, everybody. So over the past couple of days, we've gotten a SITREP, a situation report on where we are with RPAS and how we've been moving towards making it a reality. Over time, ICAO has been tweaking some of our standards, our documents, to incorporate RPAS. But the first big package of standards has recently been circulated to our member states for comments, and those are the Annex 1 licensing standards, which will be reviewed by the Air Navigation Commission in the coming days. Following those standards, the RPAS panel is working on other packages for aircraft operations, airworthiness, just to name a few, and they will also be coming out to comment in the not too distant future. So a lot of the work that we've discussed is really coming to fruition as these standards become a reality. This session will allow us to reflect on where we are and what adjustments still need to be made for an efficient integration of RPAS. We have a great panel. The panel is made up of a European regulator, a North American air navigation service provider, involved mostly in the technology, 2 OEMs from both sides of the spectrum, large tin and small UASs. And without further ado, I want to just use, or inspired by John F. Kennedy's inaugural speech, or words in his speech, I'd like to just start this session with these words. Perhaps the RPAS UAS community should not be asking what manned aviation can do to integrate them, but instead, what can this new technology bring to enhance aviation as a whole? That being said, I'd like to now introduce our first speaker, Randy Willis. Randy is manager, Emerging Technologies team at the FAA headquarters. He has primarily responsibility for unmanned aircraft systems policy in the FAA's air traffic organization. In addition to his regular duties, Randy is a United States nominated member to the RPAS panel and also the vice chairman of the RPAS panel, sorry. Additionally, Randy is co-chair of the Canso RPAS working group and participates on several other domestic and international working groups dedicated to the safe integration of UASs. Prior to coming to work for the Federal Aviation Administration in September 2009, Randy served as federal contractor supporting the UAS office and also served as United States Navy as an air traffic controller. During his naval career, Randy held many positions with varying levels of responsibility before retiring from the United States Navy in June 2007, after 23 years of service. Without further ado, please welcome Randy Willis.
All right, thank you, Miguel. Good morning, everyone. Great, thanks. So I'm going to impart on you, my key word for today is considerations. I don't want to come up here and tell you how we're doing things and this is the way it should be done. I don't want it to come across that way. I'm going to present a few areas and challenges that we've received and seen in the FAA, and we've worked through these particular areas, and to date, they're currently working. Now, granted, we know that true RPAS operations are not abundant in airspace today, but I will touch on areas of how many operations we're doing in which I consider they would meet the definition of RPAS. And there is some crossover that's happening with UAS that I believe we can have and receive lessons learned from that so we can apply them to RPAS operations as we move forward. So there's my area I'll be touching on. So we have policy airspace, ATM infrastructure, and some training considerations, which if you were in yesterday's session, I think we had a real good discussion concerning training and how valuable that is in order to move forward. So policy considerations, I will tell you policy maturation takes time. You need data. You need understanding to move forward and actually create policy within an organization. In FAA, in the air traffic side, it took me 7 years to create a policy in which was stable enough that can be put into print. Before that, it was an interim policy, and it was changed quite often, sometimes several times a year, in order just to keep up with our understanding and the movement of a UAS integration into our airspace. And lessons learned are quite valuable from that point. We get them from the operators. We get them both from internal FAA offices to do that, and that feedback is absolutely crucial for us to move forward and create that policy to do that. So this is not a typo. Collaboration within the organization. So we all recognize collaboration outside your organizations is very vital and very important. So one of the lessons learned that I've had over the last 7 years is that collaboration within your own organization is also extremely valuable. Especially from an ANSP and regulator perspective, you need to talk, and you need to talk often in order to move forward ideas and policy in order to enable ideas and thoughts that are out there. We found that this collaboration has helped us greatly to do that. Obviously, there was some discussion concerning before we move to a point we need to have safety in mind and actually document safety risks and hazards that exist with this emerging technology in order to move forward. That is a large task to do, but FAA, we have mandate to do that, and we have done that, and we've been able to slowly move forward and enable operations in a very methodical way utilizing SMS. So airspace considerations, through that SMS, we are able to go through and basically do an evaluation of all of our airspace classes that exist, and we baselined our SMS effort. So anything that meets the baseline and the mitigations within the baseline, along with other proposals, they're able to fly in our airspace. This includes all classes of airspace, even controlled airspace. So we also take a look at, and we have challenges to enable what I call UAS to do many things. Package delivery and the discussion that we've had concerning ATM and UTM is certainly valid. As those progress and we understand them more, then we'll be able to make more informed decisions of how we want to move forward. From a UTM perspective, we need to understand what that means. I look forward to the next 2 days to get a better understanding of what that might be and how it can be incorporated or merged with an ATM environment itself. So do you really need airspace regulatory change in order to enable RPAS integration? To date, we found that there is areas that may need regulatory change, but not necessarily airspace changes for them to do that. It may be other regulatory changes to rules and regulations within your own state to enable them, or to at least account for the aircraft being unmanned. Some regulations may be as stringent as where they're only written to manned aviation, so the considerations would need to be made to look at for unmanned aviation from that. We also talked about separation standards from that today. From RPAS perspective, the FAA is averaging just over 1,000 operations a year that I would classify as true RPAS operations. And those are aircraft on IFR flight plans and flying in all classes of airspace, including Class A, above 18,000 feet, going from point to point or a mission from one point to another. So I'd classify them as RPAS operations. But we do have considerations for other UAS that want to operate in the airspace that may not be classified as RPAS, but very well may end up being able to fly under an IFR flight plan. So we need to consider them and consider that discussion, and obviously research, verification and validation of that research is very important to do, and it should be part of the thought processes as you move forward to integrate UAS and RPAS into the airspace. So ATM automation considerations. This is an area that's new to me and never thought I would start being able to knock on people's doors saying, hey, I need your help, but I needed their help. So ATC automation is very important for multiple reasons, and the things that are in place today to enable air traffic and the controllers to do their job is very important. One thing I found out is that there is a very long lead time needed in order to make automation changes into the current systems that we have today. So to identify the requirements and the need early is an understatement. So you'll need to do that very early and get that into the system from that. From what we've learned so far, we found that we've needed to make modifications to ERAM. Just because of the current flights that exist today are typically not a horizontal departure, as most are familiar with. And I'll explain that a little bit. So a horizontal departure to me is you leave and you start going east or west or northbound, and you go to another point. It's typically 5, maybe 7 miles away from the airport. Well, in a lot of our operations that are currently being conducted from RPAS, they use a spiral technique where they would depart from the airport, and it's more of a spiral departure up into the upper classes of airspace for that. Well, ERAM had problems recognizing the flight and updating the flight plan and keeping the data block on the aircraft while it was spiraling up instead of a horizontal departure. We went in and made corrections to that, and now it's able to keep track and understand what the flight is all about and what they're doing. Also, information for performance characteristics for the aircraft is needed in order to put it into the software to allow tools for the air traffic controller, such as conflict probe. So we've had to go and put that in there too. Last year in 2016, we moved forward based on a tremendous amount of feedback and need from the controller community to start standardizing what a loss link procedure might look like. Although we haven't gone past a dedicated squawk code, 7400, we are in great discussions with figuring out what an actual procedure would be, both within the FAA and certainly within the RPAS panel here at ICAO. That is an area in which we're trying to mature and understand what that is from that point. So training considerations. I think some of it was touched on yesterday, but I'll tell you, it's still a major challenge today within the FAA. The terminology alone is daunting to ensure that everybody understands and everybody has the same meaning for the same things that we're doing. So there's multiple new terms that's been associated with unmanned aviation, and those are getting out there to do that piece. We need to ensure that all aspects of the aviation workforce has a better understanding and education of what the new terms are and how they are applied to flying in the airspace. Performance characteristics, yes, there are a lot of variabilities with them, but that's not new for training-wise, so it's just as valuable that they're included into the training that's needed, so everybody has a better understanding of the capabilities of UAS or RPAS. And of course, the contingency planning. Again, a lot of new areas to be explored there, and to recognize is a true holding point needed. As mentioned from Mike Lasson in the last panel, that's a great question. It's a research question that needs to be understood and see if it can be incorporated in today's structure for approach plates, departures, and all that other things. So I'll leave you with a few things for moving forward. Everybody knows this is a very fast-moving industry, and so you ask yourself the question of how you can be nimble enough to keep up with it and enable it as far as you can and as long as you can and still be safe, and collect the information and data from that in order to inform you and how you can move forward. The appropriate research and development needs to be done. There's been a lot of R&D accomplished for UAS and RPAS integration. I'm not overly convinced that the appropriate research and development has been done and in a harmonized and very methodical way move forward to do that piece. So we need to take a look at that and make sure that we're spending the resources and money the right way in order to really answer the questions we need answered in order to enable the technology to move forward. And of course, the maturation of the technology. I'm not overly concerned in this area. I think if the standards are there and the rules are there, the technology will be made and built and created in order to match that, in order to fly in that. But it is a significant area, and that's where collaboration with those stakeholders that are out there doing that, the manufacturers, the software developers, all those individuals that are out there doing that piece is extremely invaluable to do that piece. And innovation will drive new capability. We may not see it yet, but we will. And given the Miguel's thoughts, absolutely. What can unmanned aviation do for aviation as a whole from that part? That's a very good perspective to take a look at. I'll be thankful for being here and being able to speak, and look forward to answering any questions that may come later. Thank you.
Thank you, Randy. I think we're still tackling this question of how we're going to integrate it, we had a crystal ball and we could speed, fast forward a couple of years. How do we see it? What can we learn from this new technology that the whole RPAS initiative, let me call it that, is bringing to aviation? What can we do differently? What can we enhance in our processes for aviation? And we've seen some of the limitations of what Randy was saying about the systems used by air traffic control not being able to manage a spiraling departure, which maybe would have been unthought of, because theoretically speaking, yes, manned aircraft could do a spiraling departure. They just don't have a need for it. But I'm looking forward to your questions as we move forward at the end of the panel. I now would like to introduce Ms. Muriel Preux. Ms. Preux is a graduate from the École Normale Supérieure in 1989. She's got a PhD in molecular and cellular pharmacology, and from the French National School of Civil Aviation and Aeronautical Techniques Engineering in 1991. Since 2015, she's the DGAC RPAS Program Manager for the French National Supervisory Authority. She is more specifically involved in the evolution of UAS regulation in UTM working groups, French and European counter-UAV working groups, and international cooperation. She is a member of the ICAO USG group. Welcome, Muriel.
Good morning, ladies and gentlemen, and thank you to ICAO to have invited me to this very interesting session. I would like to share with you a few of the lessons we have learned over the 5 past years, having dealt with these aliens, which are UAS. First, I would like to make the difference between RPAS and small UAS. RPAS, we have learned here that they will have a great impact on aviation, with the modification of 18 annexes over 19. But I would like to say that it's somewhat something which is classic in aviation, with ICAO playing his key role, and we draft SARPs, we adopt SARPs, we modify annexes. But currently, we are faced with another challenge, which is the small drones which fly in our skies today, which number is really exploding, and which requires us to be very innovative and very reactive. And I would like to share the experience of a regulator faced with this challenge. A few words about current situation in France. The regulation concerning drone has 5 years now, a bit more than 5 years. The number of declared operators is continuously increasing. The companies are quite small, so we expected some of them to disappear, and they don't. So their number grows. We have new manufacturers. They are very innovative. They have many ideas to invent new projects, new applications, and we are faced with many questions concerning this sector. They create many jobs, so it's an interesting sector, but they represent a challenge. A few impacts. The newcomers are coming from very different kind of jobs, except aeronautical jobs, so they do not have any aviation culture. Of course, they represent a huge workload for the CIAs, and they have an impact on our organization and on our human resources, and they require a quick answer every day, so we have to change our working methods. Concerning the recreational use, the French regulation is quite simple to understand. It's summarized in a leaflet which is available in French and in English on our website. An interactive map is now available online, and it's quite easy to check if you are allowed to fly on any kind of point on the French territory, and to which altitude you are allowed to fly. And the data of this flight are now available for the professional sector to be used also. But we are faced with a large public, largely unaware of the regulation. We have to inform them and even to educate them, and it's quite new for us because we are not used to speaking to the general public, and we are not used to talk to non-aviation world. And another impact is on the aeronautical information service provider, who have to adapt their way to deliver aeronautical information to be easily understandable and to be very reactive and dynamic. Concerning the aerial work, our regulation relies on standard scenarios, and if an operator wants to operate according to the standard scenario, it's quite easy. He just has to declare his activity, and he will only have to require for an authorization if he wants to fly in a controlled airspace. To fly in a populated area require also a prior notification. It doesn't prevent the innovation. If they want to operate according to a specific scenario, they just have to require for a specific authorization. But even if the regulation is quite easy to understand, they didn't want to read the regulation. So we had to write a handbook to help them And even now, they didn't want to read the handbook, so we have to answer the question every day. This regulation has already been adapted. The first one issued in 2012, the second release issued in 2016, and we have taken into account the return of experience and also the return of experience of the administration. So we need an adaptative regulation concerning UAS, concerning the competencies of the remote pilots, and concerning the operational limitation also. But this first phase of pragmatic regulation will probably come to an end very soon, because they want the number of the drone is increasing, and they are expected to be used in higher risk operations. And we will never allow higher risk operation over people if the airworthiness of the UAS is not improved. So we are going to move from a regulation with operational limitation to a regulation including requirements concerning the performances of the UAS, about their navigation or about their reliability and their airworthiness. We are currently working with French industry on that kind of scenarios, and even if it's new for them, they learn from aeronautical world, and they are ready now to go to this kind of regulation. And within the next months, we are going to deliver this result to EASA. Another point is that European airspace is really complicated, and Europe is densely populated. So solutions which are validated elsewhere in the world may not be relevant for Europe. We have to move to a more standard aviation regulation and not a low-cost regulation, and we need regional validation of solutions. This US world has many newcomers. So in France, we have settled a structure which is called the Council for Drones, for Civil Drones. It has currently more than 200 members. We gather all together drone operators, drone manufacturers, aeronautical industry, the drone users, research labs, banks, insurance companies, lawyers, administrations, and so on. All these people are stakeholders of the drone sector in France, and they aim to structure the sector and to organize the dialogue amongst their members to improve the regulation and to improve the technology also. So US requires new industrial cooperation between regulators and between industrial members also. Malicious acts are endangering the sector development. And in France, we, as you know, we have been faced with terrorist attacks, but also with malicious acts with drones. Not yet terrorist attacks with drones, thanks to God. But many illegal flights over sensitive sites and over Paris city have made the government to react and to ask for answers and quick answers. A cross-governmental approach has launched 4 working groups gathering the Department of the Defense, Home Ministry, DGAC, Ministry of Justice, and we have worked all together with the sector, with the insurance companies, and so on. The French government has also funded R&D concerning systems to detect and to neutralize UAS. One of the lessons we have learned is that a regulation based on the principle that the remote pilot will have a respectful behavior and won't have a reckless behavior is somewhere an utopia, at least in France. And another lesson is that enforcement of leisure US is a huge task. So we have to help the enforcement forces with education, information, but also technological solutions. US fly at low level, so safety and security concerns are closely related and have to be dealt all together, and a close cooperation between civil aviation authorities, DoD and Home Ministry is absolutely necessary. The French Parliament has voted a law last October, and this law has introduced new obligations and new sanctions concerning US. The first one is the necessity to have a leaflet, a safety leaflet in all the boxes of US sold in France, a training obligation for remote pilots, either professional but also recreational remote pilots. All US over 800 grams will have to be registered, and they will have to have electronic identification, safety horn, lights, and first step of geofencing. The detailed decrees are currently in progress and some are already available. International standards are absolutely necessary for registration or electronic identification or geofencing, but security need requires quick response, and we can't afford to wait for these standards. Electronic identification and geofencing are very important because drones can be threats for manned aviation, but also weapons in terrorist hands. And EID and geofencing can be technological answers to mitigate both security and safety problems, but their specification cannot rely solely on the industry. Authorities have to be involved. Last but not least, systems. We have recently implemented a system to interact with to enable the operators to interact with the authorities and ask for authorization. This system will be improved release by release, but we also are currently testing a system to detect drone in airports and to avoid at least to warn pilots when there are drones near the airport. So we are currently testing in Charles de Gaulle a system relying on a holographic radar, a long-range camera, and a radio frequency sensor that gives on an HMI all relevant information to air traffic controller and to the gendarmerie, aerial transport gendarmerie in France. It enables us to validate the system, but also to work on operational procedures when a drone is detected. This system has already been testing during the Paris Air Show in Le Bourget last June, and it works very well. New systems are likely to be deployed near airports, and neutralization is still a big problem because GPS jamming and spoofing is not possible near airports. We have a great work program to improve US integration. We want to work on airspace organization and airspace regulation. We are deeply convinced that we have to modify at least RPAS organization for US, and we also have to improve the aeronautical information delivery. The ground system, we have to, as I mentioned, to deploy many systems to ease operator job, but also to detect and protect manned traffic. US themselves, they have to be improved, at least as airworthiness and reliability is concerned. And some safety nets have to be developed, such as detect and avoid and geofencing. as I mentioned, we have to be involved in the specification of this system. And when I hear about low reliability detect and avoid in some working groups, I'm a bit surprised, because what does it mean in aviation, a low reliability safety net? Concerning remote pilots and owners, they have to be registered, they have to be conscious of their responsibility, and they have to be better trained. And our regulation concerning training programs of professional remote pilots will soon evolve to be improved. We also have to work on traffic information, what kind of traffic information to deliver to drone operators, how to make the balance between safety and security in terms of traffic information. We have to work on demand and capacity balancing, and also on the rules of the air concerning US. So we have a huge program, but that's a necessity to implement U-Space, and our aim is to implement as fast as possible U-Space phase 2 at least. So we need standards. We need international cooperation, but first we need concepts concerning UTM, and we need to define what is UTM or U-Space. Of course, we will need a cooperation with the industry, but as UTM, we'll have to meet security issues probably before safety issues. ANSPs and authorities have to be deeply involved in their specification. Thank you very much.
Thank you, Muriel. And so we heard a very interesting presentation on the challenges that the regulators are having, and especially because it's dealing with a community that is not aware of all the regulations that are in place to safeguard aviation. And that's a big challenge that we have to move ahead as we go along. I'd like to now introduce Pierre Fossier. Pierre has joined Thales in 1998 following 15 years with Dassault Electronique, serving as Advanced Systems Manager in Airborne Electronic Warfare. He was notably involved in advanced studies related to the Rafale aircraft sensors suite. At Thales, he was first appointed Deputy Technical Director of the Airborne Systems Business Group, involved in radar, EW, and emission systems for combat aircraft and UAVs. He then became Vice President, Technical Strategy and International R&T within the Airspace Division. In 2009, he was appointed Vice President and Chief Technical Officer of Air Operations Divisions, which merged with Land Defense Divisions to form Land and Air Systems in 2013. He is a Chevalier de la Légion d'Honneur and was awarded the French Aeronautics Medal. He's former auditor of the Institute of Higher National Defense Studies. Please welcome Pierre Fossier.
Thank you very much. I'm very happy and honored to be here with you this morning. Actually, we were told to sort of open the thinking blue sky, so I decided that the very title of my slide would be provocative. We are in RPAS, and I put UAS. Actually, we should think on whether that P does not represent a limitation per se. Is it because we want to mimic manned aircraft? Whereas I think manned aircraft have things to say and to learn from unmanned aviation. So that will be some sort of thinking in my talk. Anyway, we will talk a little bit about the rise of drones, in other words here. We'll talk about digital, which is at the heart of unmanned aviation. Then we'll think about what does it mean to integrate US on our RPAS into as integration in airspace and with manned aviation. A couple of words on UTM, and then some elements of conclusion. All right, so the rise of drone, not much to say about this picture. The main message here is it is there. I mean, we have a business pressure. There is a demanding request for airspace from the unmanned community for business reasons. So that puts pressure on regulation, that puts pressure on technology, but we can't deny it, all right? Also, we have new business model popping up that are in the continuum between hobbies, as was described before, on commercial applications, but also eventually personal air transport via UAVs. And we see offers in terms of technology around that, okay? And that should be in a very short time frame, actually. So that's quite a challenge. So now we're going to move to digital. On that slide, I just wanted, it's not a sort of advertisement pro domo for Thales, but that's where we're involved in our different global business unit in UAVs. So the message here is we sort of involved in all segments, in the ground infrastructure, in the airborne segment, in the overall systems for managing these aircraft, also in communications and many aspects here. And the reason for that is a realization that at the heart of the unmanned aviation is information management, all right? You need to manage a mission. That mission might be commercial, it can be defense mission, can be whatever, but it always relies on information management, okay? So that leads us to digital transformation, and I'll come back on US afterwards. What is digital transformation actually? It's not because we're going to become geeks and having connected every time with our children would do, of course. It's because we realize that data is at the center of all. I mean, the value is in data. We thought the value was in the way we process data, but actually the value is in data. So these four pillars here are what we consider as the basic technology to address digital transformation. And if you put verbs instead of nouns here, you would say we need to transmit data, we need to store data, we need to process data, and we need to secure data. All right? So that's four pillars which you see many ecosystems dealing about are very important. So why digital transformation whilst we're talking about aviation? And again, forgive me because that's going to be a little of a caricature here, but if you think about the beginning of aviation, it was all about aviate, but then it came very quickly to safety, okay? Now, there is a trend to think about efficiency now, and you see on this picture, which is a bit schematic, of course, where you see how you can better manage flow between airports and things like that. How can you improve the throughput of runways? We hear about collaborative decision-making. And after all, that's all about exchanging information and data and share them. And we see that because of history and business segmentation, things are very much soft pipe. So we see everywhere in the world necessity to exchange data. So information and data is now at the heart of aviation. All right? And we see a sort of shift from safety, not that we're going to give up safety, of course, but we need to move to efficiency, because this is what we as customers, when we fly, we expect from aviation. Now the thing is, when you reverse the thing, actually information processing is at the heart of unmanned aviation. All right, so we'll see later on that, of course, we need to grow to safety, but we see a paradigm shift that aviation that came from safety is now moving to efficiency, whereas UAVs were born in digital and are moving to safety. Right? And by the way, things that we see on particular on artificial intelligence is moving very, very fast, and we see capabilities of UAS like flying in swarms or being able to have procedures when they lose their data links, and sort of not moving from see and avoid to sense and avoid, and self-separation that we were planning to have for manned aviation in the latest phases of our transformation are natively here, I think. All right, and we see roadmaps associated with that. This comes from Cesar GU, where we see, in terms of course, I need to be very cautious here, in terms of automation. I'm not talking about autonomy, but I'm talking about automation. And as a professional of ATM systems, I know that even in the manned aviation arena, we're talking about the higher level of automation. So automation that comes from manned aviation is basically already roadmapped, whereas unmanned aviation is a very young, the latest children of aviation, if I may say. All right, so having said that, let's talk about what it means of integration. So practically, we're talking about integration in the physical space, talking about moving from segregated airspace to integrated airspace. We see how that could move together. We see how we can open up to certain categories, and there RPAS means something in terms of accessing to some blocks of airspace which are currently reserved to manned airspace. So, but we see the business pressure of UAS wanting to go high in altitude, so that creates issues. Of course, as we said before, when it comes to airports, that becomes really an issue. All right. Whereas UAS may be very useful in airports to see what's happening in terms of birds flying around, on assessing if the airport is safe in terms of intrusion and things like that. So one way or another, I mean, that physical integration of airspace will have to address it. Another way, of course, to see that is the system point of view and the responsibility. We know that, in particular, ATM was developed based on the sovereignty of states, having their own SP, which is fine. I mean, and an airspace is not civilian or is not military; it's the airspace. That's all. So we need to integrate that vision. So there are some defense and security issues. There are some civilian issues and safety issues. So things come together. Of course, as was said again before, we need to make sure that we have no intrusion or malicious things happening. All right. So that's another way of doing that, and that demands different administration or institution or industrial partners to interface together. All right. But I think actually we could think about, and I put that forward for you to think about that, is integration which is a more on the, what I said before, i.e. a holistic view of integration, which is to say safety, security, efficiency, all right? And of course, airspace access is part of it. But I think whilst unmanned aviation, so as I said before, comes with data management, as a paradox, because the pilot, in case of RPAS, is not on board, there are many new issues in terms of human factors, in terms of how you perceive the situation where you're not on board, all right, which may light up what the manned aviation is going to become. In other words, unmanned aviation could be an advanced vision of what manned aviation is going to be or will have to be, or at least partly. For example, data processing and management and the way efficiency is going to be addressed by unmanned aviation might light up what manned aviation will do later on. So we should consider that as a holistic view rather than only seeing that from airspace integration and the like. All right, so one of the vision to achieve that is, of course, to think about UTM. And again, one of the questions we might ask is to what extent UTM solution are going to put light on what the ATM systems evolution should be again, and to some extent, probably UTM and ATM systems will have to merge one way or another. But I don't want to go too deep in reading that slide, but that slide actually mimics and represents the holistic view I said before. We have to deal with security, safety, efficiency, regulation, and business as well. And that's a challenge because you can't address UTM only because you're an aviation champion. Neither can you address UTM if you're a digital champion. All right. Neither can you address that if you don't know anything about ATM and regulation. All right. So it's need probably a collaboration. So that's a new challenge that the US and RPAS put forward, is to say to address that holistic view, we need to be holistic. All right. We need to talk between us in order to provide a good solution forward. We can already put forward roadmaps, and the only thing I'll put on from that slide is that whilst we can begin to begin training programs and see some way of addressing that integration, there is still a lot to do forward in terms of research and development. And we know that if we want to stick to the foreseen evolution or business demand, as I put it forward in my first slide, we need to speed up. And we need to speed up in research and development, and I say that as an industry representative, but that has to come with the evolution or the fact that this new world is encompassed into the new regulation. And that leads me eventually to these three elements of conclusion that I'd like to leave you is on the bottom of the slide, there's two things we have already talked about, which is digital transformation, really a key pillar, the integration journey, which has to be holistic, and moving up to the slide, the technologies, which I'll share as industry, but the fact is a smart self-combination of the evolution of regulation and technology. And at that point, I'd like to quote something which I experienced with, when I was younger, which is long ago probably. I was part of a sort of think tank with the French defense, and I was very proud as a young engineer to come and see a general and saying, General, can you tell me what's going to be your ConOps in 20 years now? Because I need to prepare my roadmap. And he sort of said, I don't know. So I was desperate, because I couldn't build any roadmap on that answer. And he said, but if you tell me what you'll be able to do in terms of technology in 20 years, then perhaps we can build a ConOps together. So I was also absolutely desperate, because I realized I had to talk with him and think with him, not only on technology, right? And I think that's quite the same. I mean, the two has to go together. Right, so that's quite important. Right, so whilst I like very famous people, I think that US and RPAS are going to provide a lot for aviation. And since I've begun with a provocation, I may ask you to terminate with two provocations, this one. I think RPAS in US raises in our faces two questions. What does it mean to pilot an aircraft? And what does it mean to be a controller? All right, because funny enough, we're talking about air traffic management, but we're talking about controllers, not managers, actually. We should think about that. Thank you very much.
Thank you, Pierre. So what I take from your presentation, which was very interesting, very encompassing, is in the context of what we're discussing in this session and the additional information that the aviation as a whole will have is this wealth of information. So to operate RPAS, and I won't get into UAS as that's more tomorrow, there's got to be a link. And there's information that is flowing constantly between the controller, where the pilot is, and the aircraft itself that is flying somewhere. And just to give you an example of some of the challenges that we're having in manned aviation, in a similar topic, of course, not controlling the manned aircraft, but in transferring the information. I happen to also lead the development of the Global Aeronautical Distress Safety System. And some of the discussions that we're having there with respect to data retrieval, with respect to, of course, this is more forensic data, right? So it's not real time. There are challenges of sending all that information. So maybe there's something here in the technology that we're talking about that can benefit the manned aviation, and at least one topic that I'm familiar with, and that's the new evolution of search and rescue and accident investigation with the means to stream real-time data. So these are some of the things that I was keeping in mind as I discussed earlier, as what can this new technology bring to the whole system as a whole. With that, I'd like to now come to our last presenter, and Larry Lay is current portfolio manager and integrated airspace operational efficiency solutions for Boeing Research and Technology, their airspace operational efficiency group. In this capacity, he delivers Boeing's significant manned and unmanned aircraft performance knowledge, onboard ground communications, navigation surveillance technologies, and systems expertise, and airline operations understanding and support of air traffic management modernization initiatives and programs globally. His role to deliver integrated airspace optimization and capacity enhancement solutions, which advance ICAO's aviation system block upgrades and next-gen SSR modernization roadmaps, has resulted in Boeing's successful unmanned traffic management RFI submission to the Drone Enable event tomorrow. I think you will see a very interesting perspective from the OEMs that we're familiar with in this house at ICAO, because those are the ones that we deal with most in manned aviation. So welcome, Larry.
Good morning, everybody. Bonjour. It's an honor for me to be here today, and I thank ICAO for the invitation to speak with you all this morning regarding what Boeing is doing in the area of autonomy and how that applies to unmanned air systems or remotely piloted aviation systems. So when I was chatting with Miguel prior to the event about what we were going to talk about, I kind of walked through 3 or 4 different initiatives that we currently have underway today before we ended up talking about the one that I'm going to address. You know, we could have talked about what we're currently doing in beyond visual line of sight operations. We've have, with our in situ subsidiary, accumulated over 1 million flight hours with our ScanEagle system, and it will initiate, or it has initiated, beyond visual line of sight commercial operations in Australia for a commercial customer. We also talked about what Jeppesen is doing in the area of its portfolio of nav data, charts, NOTAM management systems, PIREPs, systems that leverage the increased connectivity between air and ground, and how it is making it easier for both pilots to manage aircraft as well as for airlines to operate their fleets. But we decided to talk about what Boeing is doing in our efforts to test, develop, and hopefully deliver an unmanned freighter aircraft in the 2030 timeframe. And we are in dialogues with customers regarding this various capability. Righto, so in the area of autonomy, it is clearly an increased presence in our life. And it is going to change our life and the capability of ourselves as humans in significant ways over the coming years and decades. And its application is ubiquitous in terms of vehicles and small UAVs, trains, and in unmanned air systems, where you see a Scan Eagle system being launched. So it's going to change our world in a major way. And as it relates to autonomy, Boeing has been involved in automation solutions for decades. If you think about it, when airplanes transformed from paper and wood to mechanical systems, to electrical systems, to where we are today, we have been present in the transformation and the application of automation as part of that journey. And as we look into the future, we see how this automation is going to transform itself from the seabed to space. And as a company, we are committed to playing a significant role in its application as we move forward. Now, having said all of that, of course, it goes without saying that safety for us, like all of you here, but safety for Boeing is an enduring value, and it is a value that we take very seriously. So as we go forward with looking at autonomous solutions for larger aircraft, we're building off of the expertise that we have developed in partnership with industry, with universities, with regulators worldwide. So in today's environment, aircraft are very autonomous. You have auto flight, you have the capability of auto land, thrust management, navigation, systems management, and how automation is integrated into that platform, and then of course the airplane health and monitoring reporting. So that exists today. So as we look to the future, what will exist, what needs to be addressed to address, let's say, more autonomous capability within these unmanned systems. And this goes for, I think, everything that we're talking about in this session during this week. You've got, and what we're looking at and how we see it is in ground operations, how do you automate the pushback and the engine start, the application of electrics, hybrid electric capability, automated taxi, taxi roll-off, off-roll. In flight operations, obviously, sense and avoid is a topic that that has been discussed here, and quite rightly, for the past couple hours. Flight path optimization. I think that how we can optimize flights more efficiently and how manned flight will interact with unmanned flight is absolutely critical. Contingency planning, we've talked about that as well, and we're very much focused on that. And then lastly, outside of the platform itself, the infrastructure and the environment in which the platform is going to will work. Integration into the airspace, how it will be managed, how it will manage within that environment. Cooperative trajectory management, and how that interfaces with other platforms that are operating under a similar construct. Conflict management, how do you disaggregate conflicting flight plans in a real-time cloud-based environment is critical. And then once again, the health management activity. So like all of us here, we learn by doing. And so we have had for the past 5 years a flight R&D testbed initiative called the Echo Demonstrator. And under this activity, what we have focused on over the past few years is testing technologies from the whole construct of the airplane system environment, and validating it. And since 2011, we've validated over 50 technologies which have had an impact in environmental solutions in terms of reduced emissions and reduced noise, reduced operating costs for our airline customers. And now we're beginning to look at how do we employ automation and increase the level of automation as part of our future testbed activities. So in this year, we'll be flying a 777, and we will be looking at smart cabin activity and the ConOps around a cabin in which decisions are made, or increasingly more made for pilots as part of an engagement, as well as the connectivity between the cockpit and the ground. And in next year, we'll be flying a 787. And once again, we will look at increased levels of autonomy with this platform. We'll also be looking at the use of hybrid electric concepts and technologies. All of these capabilities are shared clearly within our company. They are derived through collaborative initiatives with governments, with industry, with academia. And we look forward to continuing to build on the automated capabilities that are found within these platforms that will lead us to what we hope would be a freighter that would be unmanned in the 2030 environment. And of course, this assumes that the technology is ready. It assumes that the regulatory environment is ready for this capability and technology to be employed. And of course, we look forward to working with our partners to ensure that the enduring value of safety that we have with all of our solutions is applied, of course, to this platform, to this technology, that this technology would fly in an integrated airspace with manned flight and with other unmanned systems. And that we look forward to partnering with those on this journey as we begin this, continue this transformation of autonomy into a future where unmanned larger aircraft may very well be flying. Thank you very much.
Thank you, Larry, and it's interesting to see how manned aviation OEMs are moving towards RPAS, and it'll be interesting to learn more. Maybe we'll have some questions on that subject of the plan of the integration of RPAS into manned aviation components. We received several questions from the audience, so thank you for being active as the presentations were taking place. And I'll start, some of them are similar, so you might not get the exact one that you asked, but we will discuss all the topics of the questions. It's always a good problem to have questions. And so the first one is, since inevitably some solutions will be developed for UASs and RPAS operations, for example, 4D trajectories, flight management systems, how do you see those solutions being implemented on manned aviation to reach a sufficient level of airspace homogeneity for proper integration? So I think, Randy, you might be the best to address that first.
So I think from a air traffic perspective, ultimately we would provide service provision like we do with manned aviation today. I mean, in state, we would ensure that all the applicable things are done and ensure that the regulator has done their job and allow them to fly in that airspace, and we'd provide air traffic service provision as we do today with it. There will be probably some unique performance characteristics to be understood, and perhaps either approaches or departures may be a little different than manned aviation today, and those would need to be learned and understood also. But certainly not insurmountable.
Anybody would like to add anything to that? Pierre?
I would probably put two elements here. First of all, seen from the ATM system, an ATM considers a manned aircraft as having a flight plan, right? So if you consider a UAV in general, what is it a flight plan for a UAV? When I use a UAV personally, do I have a flight plan? I ain't got any flight plan, actually. I just want to take a snapshot from the wedding of somebody, all right? So we'll have to introduce new concepts of operation so that the ATM can embed a new concept of operation. I don't know how, but we need to work on this one. So this one. The second is leveraging what I said on information management. There is lots of research here, and it will come on the certification issue, right? When we began with UACs, the first reaction was to say, look, you have to be 25, 25, 21 certified, okay? And the certification process has to be deterministic. So there is a vast area of research on how advanced software might be certified without deterministic evidence, all right? And I think that fits very much with an evolution of UASs. So these are two areas of research which we need to work out.
Thank you. And I think it's also that integration that has been mentioned several times over the past couple of days of the integration between UTM and ATM and how that is going to happen. I hope that answered the question. Mr. Cizi.
Thank you, Miguel, and good morning, everybody. Yes, I am the author of the question. Yes, what I think deeply is that we will have to find solutions for US and RPAS, and at some point, if we want to reach a real level of integration, those solutions will have to come on board manned aviation. This is obviously the case for DAA, detect and avoid. And on my opinion, being in ATM for a long time, this might solve something that we never solved really, which is the mixity of the circulations, combining gliders, balloons, other things in the same airspace. But as you said, Pierre, I think it will also push the ATM system to have a real 4D management, knowing that we will perhaps not plan a flight from A to B, but a trajectory. And there are a number of features, but the point I think which is really important is that UAS is not a question for UAS people. It's a question for all aviation, and we have to consider the potential to improve manned aviation via UAS. Thank you.
Want to respond to that, Pierre?
I don't know if I may, but I think that's, thank you for this remark, which is very interesting. Let me bounce on this one. You're right in saying that one of the key issues is the sort of collaboration between the aircraft with its local intelligence, be it remote or on board, doesn't matter, and what happens on the ground. for the infrastructure. Again, to be a bit black and white, we come from a world where the pilot really commands and manages, and he manages his flight, and he asks ATM for permission to sort of adapt, decrease altitude, or things like that, or vice versa. ATM puts sort of constraints. When we see what's happening with the 4D trajectory, it's sort of a contract. Now, I think it's deeper than that. It's what is the level of subsidiarity we'll have. And the UASCs put that really at the forefront, all right? For example, the separation, okay? Do you want to track each and every UAS? Perhaps. You want to say, you guys, you're in a cluster, you just cope with your own separation, as by the way, Cesar thought we could do for en route, right? So it's an accelerator of that thinking about subsidiarity between on board and on the ground, I think. So I really with you.
Thank you. So now I want to go to another question that it's a little bit related, and for those of us that are on this side of the Atlantic, we've followed a little bit what has happened just south of the borders from Canada with regard to the drone registry, and we were interested to learn that in France you are going down that path. So I think this question might be relevant, and it's directed to Muriel. Do you think we shall aim for a global international registry database, and in your view, who shall be in charge to implement, coordinate, maintain such registry?
Well, as I told you, I think that probably we need something global, at least standards concerning formats of registration number and so on. A day or another we'll need at least interoperability because there will be trans-border operations, and enforcement forces will have to access to the information from a side of the border and from the other side of the border. But I don't know if we need an international database. I know that we need to implement it quite urgently in France. As I told you, security needs a quick answer, so we can't wait for standards and something international, but we'll implement it, and then maybe we'll have to harmonize the local implementation and at least to make the database interoperable. But an international database may come a day or another, but when, we don't know, and who will be in charge, we don't know. And now we need an answer now. So one of the problem US raised is the time frame of the answers we have to deliver. And international aviation takes its time to answer such questions because it's difficult to harmonize it. But US, they fly anyway without waiting for the answers. So we have to adapt.
Yeah, so that actually is a good time for me to pitch in on something that my colleague Chris mentioned earlier about the speed in which ICAO does things. And I know that for industry it might sound forever because our process implies consulting with our constituents, our member states, and they need to see what the international standard, how it fits into their national regulations, and how long it will take them to implement them. And that's a long process. And in fact, we're kind of in the middle of folks like you, industry, saying you're not acting fast enough, like you just said. And on the other hand, our member states saying you're pumping out standards too quickly, and we can't integrate them into our national regulations. So we got to balance that out. But I can see exactly where you're coming from with that. I have another question that I think is well suited for Larry, and that's we have a lot of experience Well, as we mentioned earlier, I mean, RPAS are not new, right? Is the technology that's evolving that is making them the development of RPAS more viable now. Yet in the military, that technology's been there, or they have more experience with it. I know that Boeing is involved in some military aircraft and RPAS. So how is that being used for civilian operations, and what do you see as the constraints of bringing that military technology into civilian regulations and common use?
Well, first of all, the constraint is that you have to operate it with other systems. In a military environment, you have military control over the airspace. So you pretty much can, I mean, you've got your concept of operations on how that platform will be operated, but you don't have to be concerned about, or as concerned about dealing with other, let's say, non-military platforms. So I think that's a huge difference. And certainly, as we look at the proliferation of both RPAS as well as UTM-related solutions, that complexity is only going to grow. So really, coming from a military environment, I think it becomes less and less of an issue. I think, though, where our expertise with the application of executing military-related operations has and does play a role, or has played a role, is the ConOps. It's understanding how to engage, develop a flight plan, coordinate that flight plan with an air traffic management-related entity, to validate the flight plan, validate the mission. Did it go according to plan based on the environmental conditions that you were dealing with? Did you experience lost link? What took place during that period of time? So those I think issues are relevant. Those experiences are relevant to help inform and guide the discussion and the debate as it relates to commercial application. Now, for us, we've been flying in a commercial environment in Australia for the past 7 years. And we've had tremendous cooperation from CASA, from Air Services Australia, and support from the Australian government to foster this capability. And we have, in partnership with them, moved the boundaries of beyond visual line of sight to up to today, it's beyond 30 miles. And we are implementing a commercial service in an area of about 120,000 square kilometers in northern Australia and Queensland. So obviously, for us to do that, we're leveraging the lessons learned from the military application, but more importantly, the lessons learned from collaborating with the regulator, developing a very robust safety case that assesses all of the permutation of possible outcomes, and then implementing the plan accordingly. And so with all of that experience that we've accumulated over the last 7 years, we've gotten to a point now where we're offering commercial revenue services in assessing pipeline wellheads and the business case closes, et cetera. So it's we're building off of what we learned in military operations, but as you really move into commercial application, you're really treading on new ground, and it really requires, as I think all of the panelists have addressed this morning, the importance of collaboration with all of the aviation stakeholders in order to make this happen.
Thank you. Leslie, do we have time for one more question? One more question. So it'll be a combination question, and this is with regards to UAS operations around airports. And I'm looking mostly at Muriel and Randy. So one is slots for UASs or RPAS, especially when they have this, as you described, spiral departure and might have spiral arrivals. How will that affect slot allocation at airports? Have you guys given any thought to that? And the other related question is, in the presentations there was comment of neutralizing UASs with jamming the GPS signal, and of course that around airports can cause consequential damages to or unintended consequences to other types of operation. So are you looking at other alternatives to neutralize UASs? So slots and UASs around airports. Muriel first, or Randy? We'll allocate the slots, yeah.
Actually, just recently, the slot allocation was brought into conceptual thinking concerning with loss link contingency procedures. So the thought is, if you're going to have multiple unmanned aircraft and it goes drastically wrong with the system, you could have multiple aircraft loss link at the same time. And how do you try to account for that in the system itself? So one of the thoughts were that there could be a slot system put in place to stagger the operations initially until we know that the possibility of that occurring is extremely rare and remote for that happening. So it's initial concept discussion at this point. We have not done any research on how slots can be actually implemented or utilized in the future for RPAS operations, but it has been thought of and considered at this point.
Thank you. And jamming.
Well, neutralizing rogue drones is a big issue, and it's quite difficult first. The technologies which are currently available are Eagles, but it's quite expensive, and Eagle don't work all the day, so you have to have many Eagles to protect a large volume. It's difficult. You also have a technological solution like GPS spoofing and jamming. Well, as I said, it's not acceptable near an airport. You can spoof or jam the C2 link, but you have to identify the frequency, and if the drone is on an automatic way, it doesn't work. Automatic mode, it doesn't work. There are also other solutions such as high-frequency microwave, but we have to test them in an airport environment and to see if there are side effects, and we have not tested it yet in France. I think we need R&D on this subject because it's a very difficult problem. And there are also legal questions. Who is allowed to neutralize a drone as far as a drone is an aircraft? And who is allowed to neutralize an aircraft? So it's an issue.
Yes, I can imagine so. So please join me in thanking our panel and giving them a round of applause. I will now hand over to Leslie, and so we can go on to some housekeeping announcement, and we can go to lunch. Thank you very much.
All right, thank you, Miguel, and thank you, panel. That was excellent. And after having heard first about the ATM environment this morning, taking a look at the bigger picture, larger still than the ATM environment by itself, was very useful for us. And I like the contrast between the IFR type of RPAS versus drones, because they are all in that airspace together, and we have to deal with them all, even if this symposium is focused on one piece of that puzzle. We'll be continuing tomorrow with the other piece. So thank you very much. A couple last things. One, don't forget to rate the sessions on the app, if you would, please. We would greatly appreciate that. And we have lunch now until 1400. We will start back at 1400 to look at what's next. So, enjoy your lunch. Bon appétit.
Thanks very much. It was a pleasure.